Hello, guys. Today we'll be looking at just a short video on the magnetization after performing your MPI. So here we have a simplified Gauss meter for measuring a residual feed. So just to explain the concepts, let's say you perform an MPI on a material, especially for MPI processes that are residual. Residual type of magnetic particle testing is when you are testing, let's say, a drip pipe. So instead of continuously applying the magnetism, the material may be magnetized. This is very common when you do MPI on drip pipe or material that have very, very high uh, magnetic strength. So have very low permeability, but because I have very low permeability, it means you cannot easily magnetize them. But when you magnetize them, it's very, very difficult to demagnetize. So such materials, when we want to perform MPI on it, we normally will magnetize the material first through whatever method you use. In the case of drip pipe, we have a magnetic coil that we use in magnetizing the drip pipe before we perform the MPI test. So in that case, you don't need to continuously hold the magnet while performing your MPI. So after magnetizing and performing your MPI of such material, sometimes there is need to demagnetize the material. Why is this so? There are some cases where you do automatic welding and you have residual magnetism in the material. They can deflect from the arc of the welding machine. Then there are some other materials that residual magnetism may be very harmful to them after you perform the test. So sometimes there is need to perform the magnetization of the material after your test. So the first thing you need to do when you are performing the magnetization is to check for the residual magnetic field using your Gauss meter. So what you do, you probably will place it on the material that you are testing. If the magnetic field is greater than 2 Gauss or 2 millitesla, it means you have to demagnetize. So this material is not a very hard material that retains magnetism, but just to illustrate the point, if you look at the magnetism in this case, is low anyway, but just to test, just to illustrate, you see that the magnetism deflects the Gauss meter. This is just to show you that it deflects, but this material does not have a, okay. In this case, you can look at it now. If you look at the value of the feed indicator, you discover that it is higher than the 2. This is 5. So if you calculate, okay, it's a little lower, but in a situation where it is higher than the 2 Gauss, it means you have to demagnetize. There comes in this equipment, which is for removing residual magnetism. So it's a demagnetizer. So basically, what you do, you power it on. This one has the foot pedal. In some other cases, it has a switch where you turn it off. So what we do to demagnetize, you put it inside. If you look at it, as I'm holding it now, the magnetic field is actually drawing the material in. So when we take it in and out, even without me putting much effort, you can see that the magnetic field is dragging the material in and out. So after doing that, we come back, check it again. If you can see now, it has fallen below our 0 Gauss. So let's say after demagnetizing, we bring it out, it is still higher than the 2 Gauss that we need. What do? You take it back, you demagnetize again, you check it, you keep doing that until your value falls below 2 Gauss. That way you have completely demagnetized. I hope this helps.